Good morning, everyone. Thank you for joining us. We are going to give our guests a few moments to join us this morning in Zoom, but please feel free to go ahead and rename yourself so that the other participants can know who's on today's call. Also, we are asking that all of our guests remain on mute for the entirety of this discussion until we get to the end for some live Q&A. Please feel free to utilize the chat function. If you have any questions, we will either answer them in real time or we can present them at the end of the discussion. We're so excited to have you join us today for JU Stay at Homecoming, our first ever virtual Homecoming and Family Week, and we will get started momentarily. Thank you. Another tip is if you want to remain in speaker view, you can. Otherwise, you can also click to gallery view to look at the other participants on today's call. If you're feeling comfortable and would like to turn on your camera and give everybody a wave, we would more than happy to say hello virtually. And again, we're just giving our guests a few more moments to join and we'll get started here pretty soon. Thank you. One last reminder for everyone is that we are going to be recording today's session so that we can share it out with our families and alumni after today's event. So please just know that we are going to be recording this. Again, feel free to utilize the chat function if you have any questions. We have a few members of the Alumni and Family Engagement Office on the call. They're happy to answer questions in real time, or we can also present them at the end during the live Q&A. I'm going to go ahead and get started. My name is Marianne Jolly. I am the Director for Alumni and Family Engagement here at Jacksonville University. We are so excited to have this year's homecoming pivot to a virtual setting so that we can still reach all of our alums and our families across the United States and the world. Today, we thought we would update our student for the day and actually recall this to be Student for a Day in the Future. We're very fortunate to have Dr. Murat Teriakoglu here to speak to us about the STEAM Institute and the future collaborative space for our students on campus. So thank you again for joining us. We hope you enjoyed today's discussion and you can have a little bit of a look inside of what our students are doing and will be doing here on Jacksonville University's campus. So without further ado, I'm going to pass it off to Dr. Murat Teriakoglu. He is our Executive Vice President for STEAM Initiatives here at Jacksonville University. And please let us know if you have any questions. Thanks.
Thank you so much, Marianne, for the lovely introduction. I couldn't be happier to be talking about STEAM today. Usually to me, STEAM means vapor, a form of water, but in this sense, we mean something else. And basically what we mean is written right underneath STEAM, it's creativity infused STEM education. And what do we mean by that? That's what the presentation is about today. So let's start talking about the status of STEM education, not only in the United States, but around the world. The countries with the most STEM graduates, when we look at it, United States is the third in the world. And if we correct this per capita, we're well behind China and almost at the same level as India. But United States being a technology leader, definitely more STEM degrees are needed. And this has been the focus of many administrations in the past, starting with the Clinton administration. And this focus has helped the STEM education get better in our country. Nevertheless, there is still some severe STEM degree shortage in the United States. So moving on, how has the approach been to STEM education? And this is the kind of education I went through many years ago. It basically uses what's called convergent thinking. It's using logic. It's, you know the facts and you arrive at an answer, and there's only one correct answer. And the same exercise is repeated over and over and over until we basically stop thinking and start reacting as if it's a reflex. In this situation, the problems, what we mean by problems is the end of the chapter problems. They are all very well defined. All data are provided, and there is one correct method to solve it, and there is definitely one correct answer at the end. This type of approach, using this logic and there being only one correct answer, is what has been practiced in STEM education for over 50 years. So when we look at our brains, obviously we have two parts, the left side and the right side. The left side is the analytical side, that's where we think logically, we have all the equations and mathematics and all of that. And on the right-hand side, we have the creativity, the artistry, dreaming, all of the imagination is on the right-hand side. Now, the left side of the brain is the one that has been overused in the STEM education, traditional STEM education, but the right side of the brain is not used at all. So we're completely neglecting the power of the right side of our brain in the way we educate STEM graduates. So what is the consequence of this? Well, this is well known. We all like comfort zones where we feel safe and in control. Around the comfort zone, there's a fear zone. That's if you're not used to what we're seeing or being asked to do, there's a lack of self-confidence. We may find excuses, or we may be prone to what other people think about us. Now, if we overcome this fear zone, on the other side is the learning zone where we acquire new skills, we deal with challenges and problems, and we extend our comfort zone. And then the real growth happens. We find purpose, we live our dreams, we set new goals, and we conquer objectives. So overcoming this fear zone is a very important task for all of us, regardless of whether we're in STEM or not. What traditional STEM education does is to build a very well-defined comfort zone and a huge fear zone around it. So let's talk about the STEM comfort zone. First of all, there was this article about a year ago in New York Times. In a study, it was found that engineers make really good salaries when they graduate, fantastic salaries. But over time, English majors catch up and surpass engineers. And the reason was engineers were not as adaptable to changes, were not very responsive to the challenges, and they remained in their comfort zone. because the fear zone was large. So the emphasis only on the analytical skills in the traditional STEM education reduces the prospects of the long-term success. On top of it, do we really prepare our students for real problems? Because in real problems, we usually know only the symptoms. Yes, there's a pain somewhere, but usually we can see the symptom, but the real problem can be somewhere else. The problems are never well defined, and they may remain undetected for a long time. There may be limited data or no data at all. There will be definitely multiple ways to solve it. And basically divergent thinking, the type of thinking that involves the right side of the brain is needed to define the problem. And that's what's missing in STEM curriculum. So we started envisioning STEAM at Jacksonville University. We were cognizant of the STEM degree shortage. So yes, we need people to provide for these STEM degrees, especially in computing and engineering. We also know that there is a coming wave of automation. The latest news is that 95% of people will receive a command from a robot, whereas 5% of the people will tell the robot what to command. So we really would like to be in a position to train our students to be in the 5%. And our country will retain new jobs created by automation, and these will be the ones that require creativity. Creativity is the right side of the brain, is the side that we need to develop for future success. So we already covered this a little bit. We emphasize convergent thinking, but artists use divergent thinking. So how can we combine these two ways of thinking and get the best out of both worlds? Well, they are both needed in what's called human-centered design thinking. So our approach has been, why don't we introduce this human-centered design thinking into our curricula and build those skills over and over and over again, so that we develop a different kind of skill set for our students and alumni. And I will mention these in a few minutes. So let's compare this human-centered design with traditional design. And for this, I chose this magnificent product that was designed in the 70s, Concorde. It's no longer being used, but it's an engineering marvel. The engineering design was built on the technology and the science. So it was a supersonic aircraft that could fly over the Atlantic within 2 hours. So when this was being designed, people thought, oh, everybody will purchase one. The result was no airline ever purchased the Concorde. It was primarily used by British Airways and Air France, the two developers of this airplane, and no commercial air carrier airline company ever purchased a Concorde. So although technically it was superior, it wasn't a product that was needed. So let's compare this with something that became a part of our lives. And in this case, it's the iPhone. And this is a fantastic example of a human-centered design. Engineering went into it, technology, but along with it, arts, how it feels, how it looks, and also the human behavior, because such a product did not exist. So the designers of iPhone looked at the human behavior and how they can help the daily lives of the future users of this product. And the result was a revolutionary product that transformed our lives. And the last number I saw is that 1.5 billion, with a B, uh, smartphones have been sold since the inception of iPhone. And in these human-centered design experiences, we know that we can develop critical thinking and problem-solving methods. Definitely, we can build fantastic teamwork skills and also communication skills. And these three are basically what most employers have been saying. Those are the three critical things that are needed. In fact, the English majors that surpassed engineers, they were doing well, better than engineering graduates in these three areas. So this is well known. The industry has been saying this for a number of years now. So how do we approach this? Here's a revolutionary idea. Why don't we engage the student in designing solutions for real problems from the very first year until graduation? Why don't we ask them to think outside the box and maybe unleash their potential and develop solutions for problems? It can be about the world, it can be something in their daily lives, it can be a very technical, well-defined need, but let them think about it, let them develop solutions. And as a matter of fact, this spring, there will be a course between visual design, electrical engineering, mechanical engineering, and marketing students working together on sustainability problems, a well-defined issue in Florida, and they will develop solutions and try to build a business case for these solutions. So this cross-departmental different ways of thinking, bringing students together and letting them think and develop and use their creativity to develop these solutions is definitely what we would like to build on. So in the end, we want to get rid of the comfort zone and the fear zone and all of that, and it becomes just basically one zone where the students are comfortable to learn and grow without fear. In other words, they become comfortable being in uncomfortable situations. And what does that mean? Well, there is a challenge in front of me. I don't know what this is all about, but I'm not afraid. I know how to approach this. Let me ask some questions. Let me read the literature. Let me talk to some other people who've done it in the past. Let me gather the knowledge. Let me build a team. Let me bring people with diverse backgrounds and attack this. So it's not going to be just thinking and developing solutions on their own, but bringing the resources that they need to develop an idea and a solution that they can build on. And where are we going to do this? Well, we have recently named the old Lazara building right across from the parking lot at Jacksonville University campus, the new STEAM Institute for Student Design. We would like to renovate this building, and when the renovation is complete, the first floor is going to look like this. And let me give you some highlights of what we're talking about. There's going to be a film studio. And there's going to be a 3D design. These are visual arts activities. And we would like to put them at the same place with engineering students so that these students can come together in what we call a creative space. Right next door to the creative space will be a maker space. There's going to be equipment there where they can turn their ideas into something that they can hold in their hands. So, for instance, in film, there may be needs for some automation, a little product that will help them do a certain task. They can design it, they can think about it, they can design it, and then they can make it, and then they can use it. And this is what the creative space is going to look like. It's basically there for the students to start talking, and really what I call is unleashing their potential. On the second floor, there will be another design center that we're going to use. This will be more for courses. The first floor will be open to all students where they can work together. And let me give you the layout and you can appreciate the variety of activities that will take place in this building. There will be a trading room where live stock trade decisions will be made. Jacksonville University has a mutual fund, and the latest figure was it had about $750,000 in it, and it's managed by students. Here, the students will be asked to do, buy, sell, hold decisions all the time. The digital design is, I show you the rendering on the second floor. Right next door is media screening. So if we are going to have a little film or something else, we can go to the media screening room. There's going to be virtual reality, strategic communication. And we think that communication is a very important part of STEAM, so I invited the communication department to take part in this endeavor. Digital forensics, and I will explain this a little bit better when I talk about cyber range. These two go together. Autonomous systems, robotics and drone design, product design, freshman design, and in the corner there will be a room for the math faculty to help us out with the math challenges that we may face. So cyber range and digital forensics are about cybersecurity, and I want to take a moment to talk about cyber range and what it means. There are those jobs, and pilot is a fantastic example, where on-the-job training is not an option. If you knew that the pilot just recently got a degree, has no flying experience, but a fantastic degree from a university, you wouldn't feel comfortable flying in that aircraft because some flight experience is needed. That's the reason why flight simulators were developed, to give that experience to the students while they were in college. Now, the same applies for cybersecurity experts, because you cannot afford to have a fresh graduate without any cyber combat experience to try to fight a cyber attack at the first time. You need graduates who have the cyber combat experience when they're in college. And this cyber range that we're trying to build is going to give the students that experience, a simulated cyber attack by using which they can develop their cyber combat skills. And this is what we've been trying to build. This will not only serve our students, but also our industry in the region. We've been in contact with several companies in the region, and we're trying to bring this to Jacksonville University campus. So stay tuned. Okay, and then let's talk about what else we can build? What can we do? And I already gave the hint, bringing students together from various academic backgrounds and asking them to work together. Let me give you several examples. For instance, in engineering, we have mechanical design, manufacturing, mechatronics. In computing, we would have cloud computing, cybersecurity, which I have just talked about. And if you look at health, you have rehabilitation, kinesiology, occupational therapy. So let's look at the intersection areas. So between engineering and computing, we have drones and robotics, autonomous systems. Between health and engineering, adaptive rehabilitation devices, biomechanics. And between computing and health informatics. Now, if you look at the sweet spot where all three meet, this is where we would like to build these STEAM programs, STEAM signature programs. And in this example, it would be smart biomedical systems. And you can take this approach to many other programs. And let me give you another example. If we were to look at mathematics, computing, and business, this sweet spot in the middle would be occupied by what's called data science. And we are in the final stages of developing a data science program at Jacksonville University and offering it for the first time starting in fall 2021 academic year. So in conclusion, STEAM is creativity infused STEM education, where we, instead of asking the students to listen to what we're saying, we're asking them to unleash their potential. Go think, do, develop a solution, and learn how to bring different resources together to overcome a challenge. For that, there will be design projects throughout the curriculum. And in the end, what we would like to do is there won't be any comfort zone, or maybe the entire, how they operate will be completely their comfort zone, depending how you look at it. But there will definitely be no fear zone to overcome. They are just comfortable in learning and growing. Thank you for your attention.
Thank you. I was wondering if you could tell our guests today a little bit about your personal experience and background.
Well, I'll be happy to. I grew up in a family business of manufacturing. My late father was a college professor turned entrepreneur. So I learned over the years all the pains of family business, the manufacturing, and how much of a gap there was between academia and industry. So when I came to this country about 30 years ago, I wanted to customize my background based on what I saw what was needed. I needed a little bit of business, I needed a little bit of this, a little bit of that. So I got degrees in engineering management where I can bring the business way of thinking and engineering together. Later on, I got quality engineering certification, and I got a second PhD in materials and metallurgy because I wanted to reinforce my technical side. After I started teaching, and this was about 16 years ago, I got pretty bored teaching the same thing over and over again. And when I'm bored, I noticed that the students are bored as well. So I challenged myself to find some meaningful problems for my students. So I reached out to several small businesses, and this was in Pittsburgh area. and ask them, what are your problems? Give us the problems that you want to see solved, but maybe you don't have time. I'll give it to my students and we'll give you an answer. We'll give you a solution. It may not be the best solution, but it will be a solution. So I started bringing these to the courses, and what I saw was magnificent. Those students who slept through the lecture, who showed no interest, who were not the best type of students in the most academic sense. They woke up and they became motivated. They would spend the entire weekend downloading software, designing something. They were having so much fun that they missed the Steelers game, which is unforgivable in Pittsburgh. Um, so I knew that I tapped into something I did not know about, and that's what is called intrinsic motivation. When the activity is so good that the reward for the activity is the activity itself. So we helped so many companies by bringing these simple solutions, and the outcome was fantastic because we could provide a solution that would cost nothing or maybe a few $100s to solve a problem that cost the company thousands of dollars. So in one case, about $1 million. So this creativity, this unleashing the creativity of the students and giving them an open-ended problem and letting them think, read, learn, develop, that has so much potential, and it's an untapped resource. It's not done very frequently, in fact, not done at all in many institutions. That's what we are trying to bring to Jacksonville University.
Thank you. I did want to open it up for any of our guests that have questions. You can feel free to drop them in the chat or unmute your mic and ask them. I did receive one question specifically about the Lazara building and the renovation. Where are we in that process, and when do we expect to see our students learning in there?
Well, that process has already started. We're not going to wait for the renovation to be complete because of this coronavirus pandemic. We have to put that renovation on ice a little bit because we were in the middle of fundraising, but everybody is tightening the belt, understandable. But we're not going to wait until we raise the funds to use the new STEAM building. So visual arts faculty has already moved in. I'm on the second floor. Engineering faculty is moving in, and I am developing a plan to move other faculty in there to bring some students and provide the type of education that we had envisioned. So when is it going to be active? It is active now, and it will become increasingly more active in spring.
Wonderful. And are we recruiting students specifically to the STEAM Institute, or are they coming through other disciplines?
Well, STEAM Institute is basically an idea. It's an idea where we bring down the cross-departmental, sometimes cross-college walls, and we work together for the benefit of the student. There is no reason why engineering students cannot work with business students. There is no reason why electrical engineering students cannot learn from visual arts students or vice versa. This bringing them together and giving them a challenge in which they can work together and bringing their strengths to the table is basically the future. STEAM Institute is not an academic program where we bring students to, but it's an environment that we provide to the students where they can be involved in those design projects.
And we had previously spoken about a few of those projects that they're already working on together. Can you shed some light on some of this current student projects and collaborations happening on campus?
Um, I think the best example is yet to happen.
Okay.
And this is, we received a grant. It was the top rated proposal to a private funding source. We submitted this proposal to bring the visual arts, mechanical, electrical engineering students and business students together. And so that they can work on a project related to environment, a local environmental issue. And if you can imagine can you imagine what the largest environmental issue is in Florida? Does anybody have an idea? I didn't know, I had to look it up. It's septic tanks. Because of the soil, because it's basically sand, the septic tanks are failing, and the leaks are finding themselves go into the water stream, and it's becoming a larger and larger problem. So we will ask these students to go look at the septic tanks and learn about septic tanks and develop a problem that will help with this environmental issue in Florida. Now, it can be different things. It can be multiple teams developing multiple solutions, but it has to be about this environmental issue. And in the end, their solution will have to be something that they can build a business on. So that's why they are required to do a market research, a patent survey, and put together a business proposal, which they will have to defend to a group of venture capitalists. So this is the kind of complete experience that we would like to give. Now, we've just started, but this is the best example I can give. There are other smaller examples I can provide, but this is the best one so far.
Thank you. My last question was really for parents. If this is something their students are interested in getting involved in and exploring here on campus, we know there's not technically a specific major, correct? But what is their best first step into finding, what could be a true passion for them within the STEAM Institute?
If they are technically inclined, engineering is always an option. We are in the process of overhauling our engineering curriculum to make them design integrated curriculum. So what I advocated as integrating curriculum from day one up till graduation, that is in the process right now. So we will be switching to a design-based curriculum in engineering. Visual arts has already done that, and we are looking into finding ways where we can integrate those two programs, so there will be more arts for engineering students and there'll be more technical content for the visual arts students. If your son or daughter is into only business, yeah, we can use them. They can come over. If they have entrepreneurial spirit, we can definitely work with them anytime. We can integrate them into our projects, and we can provide opportunities for them to get involved. So right now, where these ideas will be nucleating will be on engineering and visual arts, and I anticipate that they will grow to other departments in the very near future.
And is the best place for students to find out more information through their academic advisors? I know we also have the new PODS app out as well for the university. What would you suggest?
The best person to contact is me. I'll be happy to spend time with the students. talk to them. We can create a group. We can develop the best ways for them to get involved. I'll be more than happy to guide them in their studies and how they can use their own skills and potential to help out in these projects. So feel free to, they should feel free to contact me. The best way is to reach me is through my email. And if we can provide that later on through correspondence, that'll be fantastic.
Thank you. I'm actually going to put your information in the chat right now for everyone. We also put in the link earlier. It is just ju.edu/STEAM if you're interested in exploring the STEAM Institute online. If there's no other questions for today, I do want to thank Dr. Murat Tiryakulu for joining us this morning and giving us such a wonderful session on STEAM. It's definitely one of our very exciting collaborations happening here at Jacksonville University for our students. If you are going to be attending any future homecoming events for the remainder of the day, I did just want to let everyone know you can find all of the Zoom links on the schedule, which is ju.edu/HCFW, or you can type out Family Week. And all of the links and Zoom access information will be posted there daily. But thank you again for everyone for joining us this morning. We are so excited to be kicking off homecoming this week, and we look forward to sharing in a lot more conversations, both fun meetings and also educational this week. And if you need anything, feel free to reach out to myself. I will put my information in the chat as well. Thank you so much, everyone, and fins up. Happy homecoming.
Thank you.